Today we're going to look at applying trigonometry. An angle of elevation or angle of depression is the angle made with a horizontal. The angle of elevation is the angle made by looking up from a horizontal. So if you're looking at a plane that's up around here, then the angle that that plane makes with the horizontal that you're looking up at is the angle of elevation of that plane. The angle of depression is the angle downward from the horizontal. So if we were looking up from the top of a building, looking downwards at something on the ground below, and the angle that we're looking at of that object below the horizon is the angle of depression. So to solve a problem involving trigonometry, it's often helpful to firstly draw a labelled diagram. It's really important that a lot of these geometric concepts, they need to be visualised because they are visual, they are often real world, so it is important to be able to draw a diagram to better understand what you need to find in the problem. And then if you've drawn the labelled diagram, it's then helpful to identify and draw relevant right angle triangles that relate to the scenario, and drawing them out separately from your diagram can help to distill that. Even if you are struggling to understand a problem and exactly what's going in it, if you've drawn a labelled diagram, you're showing the people who are looking at your response that you've made a start, that you understand what the problem's asking, which is the first step to being able to solve it, and then work collaboratively to be able to reach a solution. Thirdly, once you've got that right angle triangle, if you've got identified and drawn those right angle triangles, you can solve for any of the unknown measurements using the trigonometric ideas that we've discussed earlier, and then making sure that if whatever the original question is, you answer that question in a sentence. So if we look at an example here, a plane flying at an altitude of 1500 metres starts to climb at an angle of 15 degrees to the horizontal when the pilot sees a mountain peak 2,120 metres high, 2,400 metres away from him horizontally. Analyse the situation to determine if the pilot will clear the mountain. Now it's a pretty wordy question, so we can see that we've got quite a few measurements here that we've been given, and we've been given an angle as well. So we've got our plane flying at an altitude of 1,500 metres initially. He starts to climb at 15 degrees when he sees the mountain, and the mountain peak is this high, and it's this far away from him horizontally. So let's try and label the plane, the mountain, on a diagram. So if we label the plane here at an altitude of 1,500 metres, altitude means it's a vertical height. We know that the mountain peak is away from him over here, and it's 2,120 metres high, and we know that horizontally it is 2,400 metres away from him. So it's this far. Now we can see that from our plane's point of view, if he starts climbing, then he has 2,400 metres to climb at that 15-degree angle to then clear the mountain. So this is the distance that we're interested in, because if he can clear the mountain peak from where he currently is all the way up here, if he can reach over the top of that mountain, then he will clear the mountain. So to determine how far, so I've drawn the initial diagram, and then I've drawn a triangle, a right angle triangle that we can solve. We can see that it's 15 degrees, and that we can see the actual amount vertically that he's going to be able to climb if he maintains that angle. So how far is it to the top of the mountain from where the plane is? Well, if I find the difference between 2,120 and 1,500, then that's the distance that the plane has to climb vertically before it can clear it. So if I subtract or find the difference between those two, that distance there is 620 metres that he has to climb. So if he can climb above that, if x here is greater or larger value than that, then he has cleared the mountain. So let's solve for x here using trigonometry. Now let's have a look at what trigonometric function I need to use. We've got the opposite side and the adjacent side. So opposite over adjacent is tangent, the tangent ratio. So tan of theta is equal to opposite over adjacent. So that's 15 degrees is our angle. Our opposite side is x and our adjacent side is 2,400. I multiply both sides by 2,400 and I get x is equal to 2,400 times tan 15. If I plug that into my calculator, I get 643. So that means that because as x, the value that we found, is greater than 620 metres by 23 metres, the plane will clear the mountain. So what have I done? What are my steps? Well, I have drawn a diagram of the situation initially, drawn a relevant right angle triangle from the diagram that's going to help me to solve the problem by figuring out if he's going to be able to make that distance there. I've written a statement initially that says what I'm trying to show, that if this value x is greater than 620 metres, then he'll be able to clear the mountain. So then I've solved, or I've written down my relevant trigonometric function, solved that, and then answered in a statement to answer the original question, asking whether or determine if the pilot will clear the mountain. So the important parts here, to analyse the situation, means we need to pull it apart. So that's what we've done. We've pulled it apart by determining, okay, the plane needs to climb the 620 metres to be able to in order to clear the mountain. And then I've been able to extract the relevant right angle triangles from that. And then I've answered by determining if the pilot will clear the mountain. And I've said yes, the plane will clear the mountain.